So everyone, thank you very, very much for being with us let's just close the video there. Thank you very much for being with us for this event this afternoon. Can you see my slides nice and well, Steve?
Yep, they look good.
Perfect. As I say, thank you everyone for joining us for this, what is the second event in our Encode Tezos series. I'm your host today. I'm Anthony, one of the co-founders of Encode, and I'm going to be teaching you about Tezos in its entirety. Give you a general overview and introduction. This is meant to be a non-technical event, so we won't go too into the weeds, but to give you a high-level view of Tezos itself. Given that last week we talked about blockchain and what blockchain was, I'm sure Steve has or will put the slides in from last week's event or the medium, so you can go back and look at that if you so want to. But we won't assume anything too much today. We'll go through everything a little bit from scratch, and you'll leave here, my aim, with a good knowledge of Tezos. This is a tripartite series. We're doing 8 educational events. This is event number 2. We're then going into an 8-week online hackathon for you to build projects and really kind of codify that learning process you've gone through by building something, by coding. And then we finish up for the best teams with a 10-week accelerator to help you become a startup or build startups on Tezos. So lots of opportunity for everyone. You don't obviously have to go through all 3 processes. You can pick and choose. Of course, the accelerator is a selection process at the end. But we are, at least my soft goal is get as many of you through to the hackathon stage as absolutely possible. For those of you who don't know, Encode Club, we're trying to be the best place for Web3 education. We do this with great programs, things like boot camps, education series like this, AMAs, hackathons, accelerators, investing, and also help you get a job at the end of it. So if you do, as part of this process of education, kind of find yourself wanting a job or to raise money, then we'll absolutely help you do that and talk to anyone with an Encode background. We've got Vida and Steve on this call, but many others throughout the Encode community are there for your assistance and to help you really fulfill your goals in crypto and Web3. And everything we do is free, global, and virtual, so accessible to everyone around the world very easily. This is a core tenet of Encode. And if you're not sure where to start, come talk to us directly so you can fill in this form. This will come personally reach out to you, provide one-on-one support. If there's any educational things, again, if it's job related, just explain what Tezos is. Scan that QR code. I'll give you 10 seconds to do that if you so want to. And then that will link to a form for you to, if you want to kind of get started with Encode, or head over to our website, www.encode.club. And that should have everything about Encode and what's going on and in the next few coming weeks and months. Right, let's get to the nitty-gritty. What is Tezos? That's why you're all here today, to learn about the Tezos blockchain. Well, let's start with some history. In 2017, Tezos actually raised a lot of money, 232 million, in what was the biggest of its fundraisers of its kind ever in crypto, and particularly for 2017. And what I want to kind of convey to you is that Tezos is an OG, quite frankly. Tezos is one of the original blockchains in the space, and has, in my view, been a source of some of the most important contributions to the crypto and blockchain space as well. If you want to go in depth and read about Tezos, you can actually go to the original white paper, which you'll notice is 3 years before the original fundraiser, and this idea of a self-amending crypto ledger. For those of you that were here last week, this is what a blockchain is, and actually you quickly find that a lot of that content has remained fairly similar, or at least the substantive part of it fairly similar from the vision to now. So I think if that will paste, yeah, I put the white paper in there for anyone that kind of wants to have a little look through. Let's move that across just in case that comes across badly at all. Cool. So let's ask the question again. What is Tezos? Well, fundamentally, Tezos is an open source platform for assets and applications that can evolve by upgrading itself. Now, this is the dictionary definition, but we know this is actually a blockchain. This has these features we talked about last week. It's a public ledger. It allows you to build applications on it. It is self-executing. it is public, it's permissionless, all these things. We'll try and talk about what those mean specifically. But these are tantamount to the same thing, at least from your perspective. But if you want a better definition, you go for this one. It's open source. Anyone can contribute, anyone can be part of it. Now we have these things, these assets, this useful thing created on top of it, applications for which you can do stuff. And that's the most important thing, is it's not just a fixed piece of technology. It really evolves over time, upgrading itself. And I think one thing you should take away, because it's obviously difficult to assess the landscape of different blockchains, really as a new developer and Go, especially if you don't have a skill set that naturally fits one, or you don't really mind, is which ones you pick. And I think the real pitch for Tezos, and we try not to try to give you the honest truth, really, is this upgradability built in. And I think it's really set itself up for future evolution and future growth, probably better than most, if not all, blockchains. And this is a good thing, because part of it being open source and public, technological advances will be copied fairly fast. So you want a system that can move very quickly, especially at scale with so many participants in something like blockchain. So it is a blockchain. But it has a few also essential features that I would say at very least distinguish, but also make it distinct from other blockchains. And these are things we'll talk through now, but these are things that some of you already know and some of you can figure out. I've already talked about this idea of self-amendment, which we'll talk about later. Governance is such an important thing. I think if any of you look at the DAO movement now, you actually see any of you don't know what a DAO is. It's a decentralized autonomous organization trying to build a company, a structure, an organization purely out of code. And I think it raises some really fundamental and deep democratic questions, but also practical questions of, okay, it's all well and good having a system, a ledger, a whole ecosystem that runs itself effectively, or runs only with code, but you're having to make some serious design choices at the start about how you want that democracy to set in. To use an abstract example, or at least a non-technical example, I think a lot of people criticize the US Constitution because it has set a fairly firm framework of how things are going to proceed and have proceeded in the US thereafter. Well, a blockchain really makes those choices as well. What you want to make sure you have is the self-amendment, and also if you are going to fix any part of the government process, that is a very good one. So this, I think, should be beared in mind in governance. Again, the tech is one thing, but how that tech can change over time. And actually, I must admit, this is kind of more anecdotal example. This presentation, we actually took stuff out, mainly because we didn't want to be descriptive in terms of what's happening now. We wanted to give you an overview that Tezos is an organism. Saying what it is now does not necessarily mean that's going to be true in 6 months to a year. It's community run. It really might evolve in certain directions, such that even teaching you this now, I'd rather teach you some of the fundamental tenets and the most important things rather than giving you all the specifics, because you should know things are going to change. But it also has this strongly typed Michelson virtual machine, which we'll talk about a little bit later, to do with the smart contracts and the formal verification. We have proof of stake. We talked about this last week. The battle of proof of stake versus proof of work is so important that we're going to actually deal with it again here, but it's a fundamental way we do consensus. And consensus is really everything in a blockchain. So how do we, if we're going to have things run with code, we're going to have to tell everyone what's happening, what the state of a blockchain is. And proof of stake is the chosen method of Tezos, and that's very distinct from proof of work on Bitcoin and Ethereum now. And also delegation, which we'll come into in a second. But as I said, I think this actually harkens back to an AMA we did. See if I can just find it for you now. An AMA we did with Arthur Brightman, who is one of the kind of core contributors to Tezos. And yeah, I'll find it here, and I'm just going to paste in this chat. We have a transcript as well. And do go back and watch this, because there's a really key, that's me, so I can go away. There's a real key section in it where he says, Tezos, I think, has always been the first to certain trends that others have later adopted. And I really think that is true, and I do think you should go back and watch that, because it is really interesting in how Arthur looked at things and framed things. But Tezos has tended to be ahead of the game innovation-wise. I think governance being particularly the thing in the last few years. And these are the innovations it's gone for now, or things I think are the most important parts of understanding Tezos as a blockchain. And as I say, I've talked about self-amendment, which is, in simple terms, it's upgrading without a fork. For those of you for which all these words mean nothing. Think about it this way: if you have a blockchain, you're not going to get it right first time. You might have some really fundamental bugs. You look at something like Solana right now, where it sometimes just doesn't work. It's not the finished article. It can be improved. That's an extreme example of blockchains that things have stopped working. But we want to be able to iterate the tech and the code base without starting again and forking, which means like giving everyone a new token and like a new version of the protocol and like doing it that way. You want to be able to subtly improve it, and Tezos has managed to do that, or baked it in by design. Bake being a pun there, and it's important that we don't divide a community, that we have a natural way to improve or divide a community. The best example in Ethereum case being Ethereum Classic. Even you can see things like BSC are kind of forks, like it's using the same code base, but it's going about it in a different way. We don't want to divide the community. We don't want to alter stakeholder incentives. We don't want to disrupt the network effects, because this is clearly going to have a lot of problems. And because of self-amendments, we can it makes the execution costs and the cost of coordination much lower with Tezos. And this is the first thing. And actually the number of changes, the number of evolutions protocol's gone through in the last few years, even the last year, is incredible, I think, in part because of this. And again, a counterexample, look at ETH 2.0, how long that's taken. There's saying nothing about the merits of ETH 2.0. It's a very good thing. It looks fantastic. But how long this has taken is in part because the governance and running Ethereum is so difficult. And this brings us on to on-chain governance. In Tezos, all stakeholders can participate in upgrades by evaluating, proposing, and approving amendments. This election cycle has actually provided a kind of formal and systematic procedure for stakeholders to reach agreement. We'll look at the specifics in a second, but this is the reason why we do self-amendment so quickly in the Tezos ecosystem, is because governance is so sharp. And again, this is very important, because when you've got so many stakeholders, so many Tez holders, so many people that care, we need a way to come to consensus, not in a technical sense, consensus in a democratic sense, very fast. The third thing to point out is the Michelson virtual machine. It's a very kind of strong, if this is for the technical folks, kind of strongly typed stack-based VM that has a lot of functional programming capabilities, which are giving you basically a lot of scope to do stuff. Now, the trade-off is it's hard, but it gives you a lot of control of what you're doing. And obviously it means you have formal verification of smart contract code that's far easier. I think you'll find it's a bit of a learning curve, Michelson, quite frankly. I know we did our first hackathon on Tezos a few years ago. It's one of those where it's longer to learn, but the benefits are fantastic when you do. And I would suggest it makes things like formal verification of code and the auditing process a far more easier process than, let's say, the EVM or WASM, WebAssembly. So that's, again, a fundamental thing is the Michelson as this kind of strongly typed stack-based virtual machine. We've already talked about proof of stake as a unique feature. To really explain what it is, this means that rather than in the Bitcoin case do lots of work that's not important, we actually, people stake reputation. They stake their reputation through money. Like if you are a bad actor or not doing your job, you lose money. In the Bitcoin world and the Ethereum world right now, Ethereum's moving to proof of stake. In the Bitcoin world and the Ethereum world, we're actually losing time and the cost of doing silly transactions, rather than well, you're losing money as a counter to that, but you're having to do this wasted transactions. POS is far less costly, and it's, I think, far more easy to get involved because you just need to put a stake down. This also means you get delegation, which means that you don't have to be the person who is mining transactions. You can give up your tokens to do so. You can give them to others. In proof of stake, a security deposit is usually required to participate in the network, and this is not everyone has enough to put the deposit down, and some people don't want to bother. And again, delegation allows me to contribute to the network without having to do the work as part of that. Cool. So we've seen some fundamental features there. Some of these mean something to you, some of them not. You might be saying, well, I really think this just sounds like a blockchain. And that's fine. You can say that. And to some extent, all blockchains borrow from each other. So some might do self-amendment well, some might do governance well, some might do proof of stake. Tezos has just taken a strong approach on all of them, which I think you'll enjoy when you get building. But let's go back to the basics. I want you to kind of understand Tezos as a blockchain, not as the specifics of, just as a blockchain. And last week we spoke about the double spending problem. And I think this is the best way, in very simple terms, to understand what a blockchain is. And what we're trying to do is avoid this thing called the double spending problem, where I can spend money twice. Because if I can spend the same money twice, money means nothing. Especially if people quickly realize that money is worthless. Obviously, some of you saw the wormhole exploit yesterday. Wasn't quite spending much money twice, but this is where a bridge on Ethereum and Solana was hacked, and people could mint, were able to mint tokens for free. Particular hackers were able to mint Solana ETH for free. And again, once that happens, you start to devalue what the money is if you can mint it for free without any consequence. But specifically here, we want trying to avoid, for money to work, you can't spend it twice. And obviously, in the kind of traditional world, we kind of do this by having a bank sit there and be like, no, that's not your money to spend. Like, you can't spend it. No, you spent it now. Someone physically takes it or physically keeps track of it. In crypto, we're trying to replace this with a public ledger, a public database that we all contribute to. And have a consensus mechanism, a way of shouting to everyone when something's changed, in order to give us a fair state of what, that I have this, Steve has that, Vida has this, and that we can spend the money we have. But then consensus becomes important, because you need a way to tell someone that something has changed. And eventually, consensus, all it is a large crowd of witnesses observing each transaction and like saying, I think this looks right given the state of what's happened before and what else is happening at the same time. And I don't need to trust you to do this. This is what we're also trying to do, to trust any one party, because if I trust one party to have too much control over the process. But how do we retain and monitor changes to a file, to history of a blockchain? How do we verify that this history, that this thing we want to have consensus over is correct? We use this thing called hashing. This is where a blockchain has the cryptography bit, the crypto bit of crypto. This basically says something very simple. We talked about it probably a little bit, almost too much last week, which is that you can prove you have a message without disclosing the contents, and because it wasn't altered. And then a hash can be just used to prove that something matches the original. Yeah, we're just trying to verify that something's happened without seeing it directly. And we also want to see subsequent changes to files. Files as money, as data, as transactions. We want to see the whole track record of something. So if I can see the whole history of something and see it very cleanly, without having to necessarily look at every transaction individually, then I start to have confidence that these changes that have happened now are right. There's been no double spending taking place, and I want to shout and tell everyone about this in return for some incentive. Well, look, we can make a rule that states that in addition to new content, this is basically how blockchain works. The previous hash will also be an input of the next hash. I think actually we've done the other way around. The next hash will also be an input of the previous hash. So you can see I was writing these into the morning this morning. Yeah, so we do that by basically, without going into too much depth, using a previous hash to generate the next hash. There, version 2 hash equals version 2 changes plus version 1 hash. Again, all this basically says is we can examine changes and see, like, well, if this is my previous state of things, this should be the next state of things, that should include everything that's happened before. Does this look right? This is why consensus doesn't become that technically difficult. Actually, the bit that's cool is, okay, probabilistically, if I'm saying this thing happened and you're saying this thing happened and she's saying this thing's happened, has it actually happened? And can I have a confidence that this is the new state of things? Again, with a view that I want to avoid taking the risk, overly risk, that someone spends money twice. Because as soon as someone's spending the $1 twice, $1 doesn't mean anything. And this is all hashing stuff, which we kind of touched on last week. Of course, blockchains have some constraints. everyone has a little bit of authority. There's no real central authority. We're starting to trust someone to verify, and we can't. Not everyone is a small player. A blockchain doesn't have a central sense of time. Its time is a distributed server of what's happened next. We measure it in block time, the time at which blocks merge. We don't refer to any external sense of time. And because of actually the physics of doing stuff, latency, every node will learn about something in a different order. So reaching consensus becomes hard. So basically my conclusion of this little section is consensus is hard. Every blockchain has to take an opinion on consensus and how to do it. How does Tezos do it? And so previously we had proof of work. We said this before. It was the Bitcoin way of doing things, that someone completes an arbitrary difficult task and basically searching for a random number, and they find it, and then they kind of, if they do that, they must have put enough work in, and they can be trusted, and we get that they're able to mine the transaction and verify something's happened and tell everyone about it. But that's quite an inefficient process, obviously, because you're doing this calculation, and you might lose doing this calculation that was completely useless. Then there was proof of stake, and proof of stake is based on the assumption, quite obviously, in the same way that you're staking time and money to do a stupid transaction, that the one that you don't, if you've got something staked, you want to lose it. So you're not going to take undue risk. Effectively, for any given block, someone is selected in a pseudo-random fashion, and if you have a higher stake, you have more chance of being chosen. This does also, by the way, naturally means, as a side note, that proof of stake systems do kind of naturally favor bigger stakers, and that's why delegation, which we talked about earlier, is so important, that I can participate in a network, participate in a blockchain without having that much money. I want to trust people actually to do things efficiently. I want to trust some parties. I just don't want them to have undue or too much influence. There was proof of stake, and there was delegated proof of stake, which you can understand what this is, that you have delegation. In this one, you have these so-called witnesses that are elected by stakeholders of the network, and they secure the network, and you kind of people are chosen this way, again, quite good. Tezos uses kind of a blend. It uses a thing called liquid proof of stake. This is kind of getting too much into the details a bit. There's a blend of normal proof of stake and delegated proof of stake, and it's basically, as I said, validators are selected based on the amount of tokens of stake they have. So the more stake you have, the more kind of risk you're taking, the more likely you are to be chosen to validate transactions and tell everyone that something's happened. And again, your reputation, the level of trust we had is literally linked to how much money there. And again, the more people that receive more delegated tokens, we are seen as more trustworthy. People are voting with their money, which I think is only a good thing. The DPoS elements are that you can delegate, but you don't have to delegate. It's not an essential part. Anyone can be a validator. We still actually want to have, with Tezos, again, going slightly into the weeds here. And actually, I should know that this is something that's voted on fairly often. Like Tezos consensus might change very soon. What we're discussing now might not be the case in 3-6 months' time. That's nice. It can evolve over time. We can test, we can trial, we can see. But actually, in the current state of things, Tezos tried to have a fairly inclusive set of validators instead of having just a few. And I guess you can look at other blockchains, and when they have a few validators, you become at risk that if those validators go down, you've got really poor, bad performance issues. So again, what they're trying to do here, what the current governance has kind of tried to do, is set up a system that is resilient, that has a proof of stake structure, but isn't overly reliant on a few parties. That could actually be a risk to the protocol. A side note on energy consumption, you can see why proof of stake is better, obviously. If you go to this website, you can kind of, this is quite a nice one to kind of give you some general stats. This is actually a clean NFT stuff that's built on Tezos. We have got some ecosystem events coming up, but you can see that Tezos is far less energy consuming. And this is mainly due to the proof of stakeness, which I think the energy argument is a very nuanced one, really. So you should remember that whilst it is, whilst you've got to always analyze why is energy important to you, because it is not bad that good things take up a lot of energy. we don't like wasted energy, and we don't like energy wasted, particularly for purposes that are, I think this is one of the reasons people have an issue with blockchain, is they don't see the usefulness of it in general. So even the efficient systems we think could be criticized. I'm not going to get too deep into this. Make your mind up for yourselves. The good thing is, on account of proof of stake and a few other optimizations, Tezos is very energy efficient. And that's a slide directly taken from Clean Energy. Cool. So as I say, this is all great. We've got nice consensus mechanism. What if we didn't get it right? Well, you know what I'm going to say here. Self-amendment. Like, you're not going to get it right. Tezos has got it wrong in the past. Every blockchain's got it wrong. Every blockchain has its issues. And some will find models and structures that will go extremely well, which is why self-amendment and self-improvement is so important. And look, to some extent, you almost certainly see a kind of either a coalescence of blockchains or a specialization of blockchains. And in either cases, they'll borrow from each other. So again, I think it's very much in the spirit of blockchain and Web3 that we kind of borrow different things off different protocols, really. And again, you need to have a way to change, fast, fairly, and democratically. This I'm going to talk about the self-amendment process. It's quite interesting. This is more in general terms, but there are 5 stages: proposal, exploration, cool down, promotion, and adoption. They take various lengths of time. Obviously, for something like consensus takes a long time. If it's something smaller, a standard for something, that would take less time. And this picture, which I'm not really going to explain because it's kind of fairly obvious, of from voting to cool down to consideration, this kind of just puts it there. So do have a look properly in the slides afterwards. But it's as you'd kind of think. And this has to be a fairly rigorous process because we're dealing with so many actors involved. Tens of thousands, realistically, of actors, many thousands of actors who care about any one issue. Cool. So self-amendment's good and proof of stake's good. But what is the actual architecture of Tezos? What does it actually look like? Well, I think this is a nice way to look at it, which is the baker, the node, the endorser, the accuser, and the client. We're going to look at each of those in turn. The node is just a local component. It's you and I on the system. It kind of has a local knowledge of what's going on in the blockchain. It has a connection to the Gossip network. Gossip network only means here that how we communicate that new blocks being created and new history is being created, and this is the current state of the blockchain. As well as listening, and obviously a node is more powerful than just you and I. It's obviously a computer. It's something that has the ability to listen to updates to the network and kind of send transactions to the network and say, look, this thing's happened. Do you think it's true? And obviously nodes can also be kind of more powerful than that. And then we go into things like bakers, which we'll talk about in a moment. The clients here just means, can you zoom in a little? So I don't think I can, but there will be the slides afterwards. The client is the Tezos client. It's how you interface with the node, how you actually use Tezos. And the client can read the context of a blockchain, inspect the state of it, and can do stuff like broadcasting operations to the network, like a transaction. Again, this is how you engage with Tezos, the actual client itself. Bakers are the ones who are creating blocks, and a baker is effectively a staker in Tezos speak, and baking is a kind of concept you're probably all aware of, and extremely synonymous with the Tezos project and the Tezos ecosystem. But as the name suggests, responsible for making blocks, producing blocks, and they're connected to they can be very big in general. And obviously each baker is unique. And when it is selected to bake a block, this physically means that it's drawing transactions from the mempool, which is the pool of all things that happen in the blockchain. And it's wanting to be responsible for telling the network that something has happened. So that is baking, and you get rewards for it. And we saw last time, we'll have a look again, Tezos bakers. We can have a look who the biggest bakers are, what yield they get. And again, we go back to, oh my god, my connection's not private. What's going on here? I'll put the link in. I promise it's not a bad link. That's just because this is a new laptop. I've completely lost my thread here. That's completely thrown me. Anyway, baking is staking, is verifying transactions happen in the network. specifically signing and publishing blocks to the Tezos blockchain. They're so crucial. As I remember my point now. Again, it's crucial to the specific type of consensus that Tezos currently has. And again, like stress, this could change, where we both want to have lots of people contributing. So you've got distributed network, and not relying on any central parties, but you do need a minimum of 8,000 kind of Tez to participate. So if you and me or someone else who only want to contribute to the network, you're going to want to give your Tez to a baker, who you get some share of the fees in return to do this on your behalf. Oh me, oh, it's been a long day. But you and I, you should probably be a delegator, and I think this is such an important part of contributing. If you don't have 8,000 Tez, which is quite a lot of Tez, or you don't really want to you don't really bother, you don't want to set up the computing infrastructure, you can delegate your coins to a baker, and yeah, you basically lend it, and you realistically, you're kind of making a bet on who you think's got the best chance of being selected to do transactions, is the most trustworthy, etc. You've then got things like endorsers. Endorsers are like bakers, and it's connected to an account, and it computes things on a per account basis based on the baker's total stake. Like the baker, it's verifying validity of things, and this is an important kind of check in the network that our bakers are doing a kind of good job, really. So it's just something to note. Not one we'll go into too much depth now, but just something to note. Accusers are kind of important because we're trying to spot if like erroneous and fake transactions are happening. Because if they are, we're threatening the state of the blockchain. So an accuser is a daemon, if anyone knows what that means, that monitors everything. And it's looking basically for two types of invalid blocks. It's either looking for a baker that signed two blocks of the same block type, so they kind of look the same, or it's an endorser who kind of is injecting more than one endorsement operation for the same baking slot. Again, trying to put two transactions through at once. And what this will do is they will trigger what's called double baking and double endorsement operations that basically mean you've messed up, like this is not going to work, this history is going to fail, or this will not add up. You will get slashed effectively. You will get some of your stake kind of taken away. You have failed. So there is an incentive for accusers to do their job well. Obviously, if they're not doing the job well, they're wasting time. But if they are doing their job well, they're going to get a share of the kind of fees from the slashing. It's very good. So that's the architecture in general. To give you kind of an overview, nothing too controversial really. This seems similar to other blockchains. We kind of covered the key differences, and we talked about things like proof of stake, and if I go all the way back, we looked at these kind of 5 core features. But let's go kind of to the middle one, which is the Michelson virtual machine, and say that there are lots of different, speeding through that, there are lots of different language choices you can have with Tezos, and I think they've really put an investment into giving people a broad range. For the reference node, by the way, is built in a particular, for those of you that understand what this means, implementation on OCaml called OCTex. Tez rather. OCaml is just a functional programming language, a very kind of low level, that's used in kind of mission critical industries that require kind of formal proof, so the hard stuff basically. And Michelson is this low, we talked about the Michelson virtual machine, this lower level, really strongly typed stack-based language with a lot of functional programming built in. You don't want to do complicated logic with this because it's just too low level, but it can be used in smart contracts, and is, I think actually when you get into it, fairly, I found, human readable as well. So this is like, if you want to do something on a very low level with Tezos, and actually when we did a hackathon a few years ago, it was just in Tezos, and lots of good things, just in Michelson, and lots of good things were built, which fills me with glee. But you might want to use something like maybe LIGO, which is a high-level language. There's different syntax that are currently supported: Pascal LIGO, Camel LIGO, Reason LIGO. For what use? Mixer, what do you say for beginners? With workshops, they're in this series and in the hackathon when you do them. That's always the best way. And there's some fantastic docs online as well, which I'll paste a bit later. Yeah, you've also got JS LIGO as well, which is kind of JavaScript-like syntax. Again, got a broad range of things here if you come from any real background. So you'll probably want to do things in LIGO, quite frankly. There's also SmartPy, which is quite an effective smart contract language that allows you, if you're Python-based, maybe obviously if you're Python-based, you probably might have experience with Viper on the Ethereum side, but this is quite a nice one on the Tezos side, SmartPy, that allows, if you're a Pythonic, just used to that, to write smart contracts on Tezos. It's also Archetype, which is a domain-specific language for developing smart contracts that are, you're really focusing on contract security, and anyone that kind of knows is into the blockchain already knows security and kind of gas optimizations really, less gas optimization less so, are really essential parts, because again, if it's not secure, funds could get drained, just like the wormhole hack I just mentioned. So Archetype also, so you've got a lot of investment, and the Maddox Lab team, which is the research team associated with the Tezos project, and many others have done a really fantastic job at kind of making sure there's lots of different languages you can use, and lots of different types of developers can get involved in Tezos. We've also, again, we've got even more Morley Lawrence, which is if you like Haskell, you can write Michelson code as well. Side note, it should be obvious, Tez is the cryptocurrency native to the Tezos chain. You use this to pay for transactions, so utility token. So yeah, just a flag. I think most of you knew that for free. We've probably got a lot of Tez holders here, but just to flag that. We're almost done with the core bit of this presentation, but I do want to touch on use cases. So we've got some events specifically looking at this, but I want to give you a taste really. Enterprise and government is one such thing. There's been a couple of projects on Tezos already. You can understand why with things like governance, you're going to get you're going to get things like using money linked to crypto money, digital money, in to replace fiat in a way. And there's a couple of projects, Money Track, which is a payment platform for directed money, which is again payment flows, remittances, things like that. Global POS, which is an easy wallet as well. WhereNode, all of these things started to kind of use the Tezos blockchain. DigiSign is also for like DocuSign for Tezos. All of these things that you could kind of have a look at. Obviously, baking as a corporate, this happens a lot. I know that Tezos have direct partnerships with the likes of EDF and Evion, and Sword Group, and the Blockchain Group, and SmartNode. So Ubisoft, Taurus. It actually makes a no-brainer that you don't just have to have devs and specific kind of mining kind of rig companies involved. You can have corporates involved in blockchain, because again, the Tezos blockchain is an open source public resource really. You want to have lots of actors involved, especially if you're going to do those enterprise or government based activities you mentioned before. And that brings us on to CBDC, so Central Bank Digital Currency. I know Tezos work closely with Societe Generale. Concept behind a CBDC is again, how can we have a digital currency built in as part of fiat? How can we use some of the functions of the blockchain with fiat? So that's something, again, don't want to touch on it too much, that's been explored. You've obviously got DeFi. There's lots of different kind of projects in the Tezos DeFi ecosystem. I don't want to tempt fate too much, but you have got various token standards, FA1, 0.2, FA2, wrapped assets. So you're starting to be able to use a lot of Ethereum assets also in Tezos, and also seeing things that you would expect in the Ethereum ecosystem on the Tezos ecosystem as well, and even better in some cases. NFTs. I think Tezos' contribution to NFTs has been pretty huge over the last year. I think it's fairly obvious. An NFT, for those of you who don't know, means a non-fungible token, a unique asset, like a collectible, a piece of art. So that is kind of one thing to show. That TZ NFT is a nice tutorial, which I'm going to put here for if you want to build a non-fungible token on Tezos. I'll just drop it into chat. So NFTs is a massive area as well, as you would expect, really. And last but not least, well, two more things: tokenization of real-world assets and making them so they can be kind of broken up into a million pieces and sold. Identity. So can we have one of the things I love about crypto is that you have a crypto wallet, which is that I'm custodized, which means my interaction with dApps on the internet is directly linked to something I control my identity. There's no middleman, there's no one giving permission or not. So I think this is real plus point of Tezos, of blockchain in general. So that is one thing to say. And DAOs, there's been a few DAOs in Tezos ecosystem, base DAO, Homebase, all for kind of building dApps, etc. building DAOs rather, which are decentralized autonomous organizations. So organizations just built with smart contract code. So in general, everyone, that's our whistle stop towards Tezos. I've given you a few things to kind of take away. The most important slide, I think, being, if I go all the way back, this one here, which gives you kind of the essential kind of features. But I think what I want you to, you'll probably not remember those, is remember this one, which is Tezos tends to be kind of ahead of the game, and the self-amendment of governance, I think, is the most important thing, really. At least my 2 cents. So yeah, I hope you use this. This is a nice taste into Tezos, that you kind of see what they're trying to do, and that you go on to achieve great things. The big one being participate in the hackathon. I'm going to use that opportunity now to take some questions, and thank you very much for listening, guys. I'm just going to go straight into the questions, and some of them might be answered already, some might not be. The Tezos Bootcamp is not currently on the cards. We might bring it in this, I think you're referring to a kind of 8-week intense course structure, 4 days a week. It might happen, but we don't have one. This is kind of the Tezos Bootcamp right now for you to learn, but it's more of a self-learning structure. Yeah, it is similar. It's all kind of similar. I think the Tezos one has proven itself to be quite efficient, quite frankly. Just by, I mean, they've changed consensus already a few times. So yeah, I think it is similar. It's obviously similar, but I think it's very good. DAOs dominating the world, maybe. Let's see, a long way to go. Cool beans, I'm committed to learning JavaScript and Python for Tezos this year. Great. So JS, LIGO, and or SmartPy would be the way to go. I think I'm not worried about the market in general, Jay. It's again, you can't, once you're very deep in the space, whilst you feel it, you don't really care too much, just because you tend to have a long-term conviction and view on the space. So that's very important. Do you think the security vulnerabilities that PO introduces is worth the risk versus POW? Personally, yeah, I think absolutely. Obviously, it is a little. I mean, I'm not a cryptographer, so it's a little bit, I guess, but like, I think it's much more efficient in general. Leah says, are you going to launch this bootcamp later? So this is an education series, not a bootcamp, but we have plenty of bootcamps happening. Steve will repaste the link. But I would actually encourage you, especially for this program, stick to these lessons, because that will start to get into the nitty-gritty of things.
Sorry,
like
I made a mistake. I was talking about the other bootcamp.
Fair enough. So we have some starting next month. So feel free to apply now.
After?
We will be doing it again. Yes, we'll do loads. So probably then again in there'll be some in March, some in April. Pretty much every month there'll be some. So yeah.
Okay, perfect.
So do apply, and if anyone wants to drop me a personal email, feel free to do so. I'm going to put my email in the chat. The other question is, why should people get started using Tezos? This is such an interesting one. So again, I think at the end of the day, there's a few things you should bear in mind. You should assess the technology. And again, I think the best teachers in the world aren't the ones that tell you the answer. They give you the tools to find the answer and trust you to do it after that. It's also the best way to learn. You'll really learn it properly that way. So I'm not going to tell you one blockchain is better than the other. What I am going to say is this is how Tezos do it. I think they do it very well, given that path they've chosen. Go and look at others, have a play around, experience, come back. Yeah, self-amendment and full verification, yes. But go and have a look for yourself. Look at, okay, even if it's got the best blockchain in the world, what's the development experience like? Does it favor the skills that I have? We personally, I don't believe in there's going to be one chain that wins. There's going to be different ones that specialize. We're going to have multi-chain. With this in mind, experiment with it and come to your own decision. And use these lectures, these workshops every week to guide that process. Do a hackathon project, and we'll try to lead you to water. We can't make you drink. That's up to you. And we lead you to lots of different ponds, and we hope that you drink the one that actually A is in Web3 and B allows you to kind of learn the most. You have the best time. Advice for non-developers. If you're a non-developer. I actually would say stick to what you're good at, unless you want to retrain, in which case do a Web 2 bootcamp, maybe something JavaScript based is actually a quite good start. If you are into, if you are non-blockchain developer wanting to get into Tezos, again, do this course, do the hackathon. We'll have lots of basic challenges as well to kind of get you started. And we might even do a Tezos boot camp. If it's more general stuff, again, we have boot camps for kind of the more general languages as well. But I think you're here, so obviously you're interested in Tezos, which is a really great start. So do every event this week, this course, and you'll get a little bit more technical as well. We try and keep it still quite accessible, but do every event and do the hackathon. And trust me, you'll be at a good stage. You're still so early, all of you. You don't realize this. Like if this, you've got 5 years to go at very least until. No, let me say that again. Let's hope there's another ball run, which is usually when things get a little bit too hot. But minimally there, if the fact you've invested time here means you're going to be very early in an ecosystem that's still nascent. You don't lose out by being early in an ecosystem. You only lose out by not being committed, quite frankly. And again, I know that's weighing up a time cost, but I don't think there's any downside to getting very deep into Web3 at the moment. Do you recommend doing a Tezos hackathon without knowing project? I think yes, because what we try to do in a code hackathon is try and have an easy set of challenges so that you can always do something. But yeah, and also I think if you look at remember those slides I showed about the Tezos languages, it's a lot for lots of different developers. They've really tried to go. They've not gone, you learn Solidity, Solidity, come over here. It's actually the opposite. It's like, no, we're going for you Web2 developer and your stack, and there's so many different options. So yeah, we've got hackathon coming up. There'll be plenty of challenges, and again, look at the languages, see which one you like the most, play around with them, try and deploy a quick thing. The documentation is fantastic, which I'll put a link to now. Any other questions? And come talk to us. And the Tezos team are lovely as well. They're here today, but they're lovely. They'll always answer your questions as well. So that's a good any homework. So we don't formally do homework in this, mainly because we don't want to scare you off. But if I was you and I'm like enthused, I'd go to the link I just sent, and like I don't know, let's do this one. Deploy a digital asset on Tezos. Do it. So if you do it, tell me. Like I'll do a dedicated tweet about you. So I mean that's not really a good incentive to be honest. You do it for the sake of your own knowledge, but yeah, go and do it. Tweet and tell the world about it. Awesome. Well, thank you very much, everyone. I once again putting my email on that. We will see you next time for the next event in this series, which again will try and take you even a step further in your journey to learn about Tezos. We'll go more of a technical deep dive next week. It won't be me. Someone far more talented than me that will be leading that one. But we do hope you join us for that, even if you're not even that technical, because you might pick something up on the way, and it's always better to try first. So I'm just going to make sure I post the Eventbrite in, but that is next week. You will be invited because you've attended this event. But yeah, otherwise, guys, this will go up on YouTube. Thank you very much for attending today. We hope you have a wonderful evening, morning, afternoon, wherever you are, and see you next time. Thank you all.